Hi guys, back again. Right, oxidation and reduction. There are three ways that you need to identify oxidation and reduction. Now, if you're a foundation student, you only need this method, okay? I'll do this one first and then I'll go on to the higher stuff. So oxidation happens when an element gains oxygen when it reacts. That's all you need to know, and you need to be able to identify what's been oxidized and what's been reduced in a given reaction. So in the exam they'll give you an example of a reaction, they'll show you the equation, and you've got to identify what's been oxidized, what's been reduced. And I'll show you that in a minute. Reduction is the opposite. So it happens when an element loses oxygen. When it reacts. Okay, so nice easy example. If we take magnesium and we react it with oxygen gas, then we form magnesium oxide. Just balance that up. Okay, in this case, magnesium has been oxidized, yeah, because it's gained oxygen. So it happens when the element gains oxygen. So oxidation is the process and magnesium has been oxidized, okay? So we just need to get the wording right. If we want to look at reduction and oxygen together, let's look at a displacement reaction. So let's go with iron oxide plus carbon. React them together, it gives us iron plus CO2. Okay, so let's look at what's been oxidized and what's been reduced. The carbon has gained oxygen. So if it's gained oxygen, it's been oxidized. Okay? Oops, wrong one. So this has been oxidized. The iron had the oxygen to start with, but at the end it's lost it. Okay? So if it loses oxygen, then it's been reduced. Okay, so that's been reduced. And for foundation, that's all you're going to need to know. Okay. So moving on to higher, you'll need to know that. Also, there are two other methods of oxidation which we need to be familiar with. So this is the next one. Oil rig. So remember, this mnemonic works quite well. Oxidation is loss of electrons. And reduction is the gain of electrons. Okay, so here it's slightly more complex, but if you're given a reaction, and again, we can go with sodium, reacting it with hydrochloric acid is going to give us sodium chloride plus hydrogen gas. Okay, now here we don't have any oxygen, so we can't use this rule here. We're going to have to use this rule. So we need to work out what has gained electrons and what are the lost electrons. So we take sodium first. So sodium is solid here, and here it's formed a salt. So if we go back to C5.4, making salts, we know that the salt is an ionic compound, so this must be an ion. And we know that sodium is in group 1, so it forms single positive ions. Okay? Let's look at hydrogen. Hydrogen here is in a compound where it has a positive charge there. Chlorine has got a negative charge. Can write chlorine down here. Okay, so these two form that bond to make that compound. So it starts off as H+, and here it becomes H2, which is a gas, and it is no longer an ion. Okay, so sodium here has lost its outer electron to form this ion, and it loses an electron. Hydrogen gains an electron and it forms hydrogen gas. Okay, we'll just double those up to balance it. Okay, chlorine is Cl- there, and it forms another compound and is Cl- there. So that doesn't change. It's not been oxidized, it's not been reduced. So sodium loses an electron, so it must be oxidized. And hydrogen gains electrons, so it must have been reduced. Okay? So if we go back to the rules here, this one has been oxidized, and this one here has been reduced. And there is no change for chlorine. Okay, so that's the second rule that you'll need. I'll do a separate video for oxidation numbers, which is going to be for the triple group and for the higher students as well.